Hello, this is Dr. Mears. Today we're going to be learning about logic and truth tables. First, I'm going to start off with the definition of statement. A statement is a sentence or phrase that must have a precise mathematical meaning. A simple statement has a truth value of true or false, but not both. So first, we're going to be dealing with simple statements. In your do, check, and corrects, you have some examples, and these are determining if they're going to be statements or not, and that's what we're going to do for these first two examples. The first one, the train leaves at 10 a.m. This is a statement, and the reason why this is a statement is because it can have a truth value. So if my ticket says that the train leaves at 10, I would call this a truth value of true. If my ticket said otherwise, it would be false. But we can assign a truth value. That's why it makes it a statement. The second one, make the tea. Now, make the tea is not a statement because it does not have a truth value of true or false. I'm actually telling you to do something. Make the tea. So there's no true or false value that can be assigned with it. Therefore, it is not a statement. Simple statements can be joined by connectives to make compound statements. Connectives that we learned about previously are not, and, or, inclusive, or, exclusive, and if then. So now there's symbols. For not, this is the symbol for not. For and, this is the symbol for and. For or inclusive, this is the symbol. For or exclusive, that's the symbol. And for if then, it is the arrow. Sometimes in some books you will see this arrow just having one line here. Sometimes it might be a double line. You just have to check your book to see, but it is going to be the arrow symbol for the if then. Now, not is a negation. That means not doing what the statement says it does. And is joining them. And means both happening at the same time. Or inclusive means one or the other or both. Or exclusive means one or the other, but not both. And so these you really have to keep straight in your mind because this one includes both while that one does not. So let's look at these or and or connectives even deeper. Examples, decide which of the two versions of or, exclusive or inclusive, is meant in the following compound statements. So here are three examples that we're going to go through to decide whether we mean inclusive or exclusive. So number one, he is captain in either the Army or the Navy. So this is using the exclusive or because he can only be captain in one or the other at that time. So it's exclusive because it cannot be both at the same time. Number two, you may have either sugar or cream in your iced coffee. So this or is going to be inclusive because you can have both. You can have sugar and cream in your coffee. And so that sugar and cream is your both. And the last one, x is greater than or equal to 5. So this is going to be exclusive because it cannot be greater than and equal to. So greater than and equal to cannot happen. It's either going to be greater than or equal to, and that's it. So one or the other. Greater than or equal, but not both. So here's how you decide if it's exclusive or inclusive. Again, these go with the second set of do, check, and corrects. Of course, this whole video is going to just follow along with what we have been learning. Okay, next, on to truth tables. So truth tables. We're going to take the letters P, Q, R. Each letter represents a simple statement and are combined with connectives to form compound statements. Truth tables are used to analyze compound statements in order to find an overall truth value. We're going to be going through the connectives. We're going to be going through not, and, or inclusive, or exclusive. We're not going to be doing implication yet. We're going to be getting comfortable with these four, and then we will move on. So here's your negation, not for a truth table. So we're going to have a statement as P. Let's see. He has height to play basketball. So when we make a truth table, we are going to fill in our P here. And so this is our statement P. He has height to play basketball. Now, when we write not P in symbolic form, this is how we write it, not P. When we write not P in word form, he does not have the height to play basketball. Now, sometimes in your do check and corrects, they might have you try not to use the word not, which is good. It's just an exercise in your mind to try to think of other ways to say things without using the word not. But this is how you can write it. It's absolutely fine. Write it out in words and then write it in symbolic form. So we're making the truth table for P and for not P here. So P, we always fill in the same values if we just have one letter. We are dealing with just P. So this is going to be true or false. So he has the height to play basketball. If we want to what's called negate it or say not. So if this is true, then this will be false because he will have the height. But if he does not have the height, then that's going to be true. So a lot of people like to think as this is true, the other one's going to be false, and vice versa. If this is false, the other is going to be true. So there's the truth table for your negation. The next truth table that we looked at is your conjunction, and this is your and truth table. This is only true when both statements are true at the same time. So let's look at two statements. Let's look at P. Let's say he has the height to play. And let's take Q, he has the speed to play. Now, writing this out in symbolic form would be using our symbol P and Q. Writing out in word form would be he has the height and the speed to play. So these have to happen at the same exact time in order for it to be true. So let's see what the truth table will look like. So we always set it up the same way. P first, Q second. We always set up what the true and false values underneath P the same way. It gets two trues followed by two falses. We always set up Q the same way. True, false, true, false. This will allow us to actually get each type of choice. So here we see true, true. Here we see true, false, then false, true, then false, false. So we need one of each type of true, false so that we can get a true, false value of P and Q. And so when I write P and Q, I like to put the connective here and because I now know that I'm looking for both true at the same time because that's what the connective and means. So here we're going from P to Q. So we're going from P to Q. Order matters, and I sometimes use little arrows. So I'm going from number 1 P to number 2 Q. And you're going to see me do that more and more the more in-depth truth tables we get to. So true, true. Both true at the same time? Yes, that is what the connective and means. True, false. This one is false. These both have to be true at the same time, which means that this is false. False, false. Again, these both have to be true at the same time, so that's false. False, false. Again, these both have to be true at the same time. So we now get true, false, false, false. This is our last column, and this is your truth table for your connective and. Now let's move on to the connective or, which is inclusive or. I am going to be using the same statements, P to represent he has height to play, and Q he has the speed to play. So when we write the symbolic representation, it's going to be P and then the symbol for the inclusive or, then Q. When we write it out in words, we would write out he has the height, or speed, or height and speed to play. And this here, height and speed, that takes care of your both, because that's what inclusive means. Inclusive is one or the other or both. So we're going to assign a true value when either one or the other or both are true. So let's set up our truth table. So symbolic form, written form, now let's do our truth table. So we're going to set up P and Q the same way. True, true, false, false, true, false, true, false. We're going to set up P or Q using the connective or. I'm actually going to put a little or right here, and I'm going to put a little I for inclusive so I know that it's inclusive. I'm going from P, number 1, to Q, number 2. So I'm going from number 1 to number 2. So this is how I'm going to read it across the table. We're going to get into more in-depth tables, and sometimes we're going to have to read them the other way. So starting you off by making sure we're training our eyes to read it the way that this statement asks us to. Okay, so let's read it now. One or the other or both. So here both are true, which is fine because it can be both. Here one is true, the other is not. That's fine because this is true. Here, this is not true. This is. That's fine because this is the other one, so it is true. Both of these are false, so that is also going to be false because remember, it's assigned true when one or the other or both are true. So this is what the symbolic form, written form, and truth table looks like for the inclusive or. Next, let's do the exclusive or. Here's the exclusive or. I'm going to use the same statements that he has height, or exclusive, he has the speed. So it's going to be P, the symbol Q, written out. He has the height or speed to play. Nope, let's say height or speed, but not both to play. But not both to play. So here's the symbol, meaning he has one or the other, but not both. So we're going to be assigning a true when only one or the other is true. And then you can even add, but not both. Not both. You can even add that in. Okay, so let's add P, Q, true, true, false, false, true, false, true, false. And then let's do our P or Q. So we are now going to be doing a truth table for the exclusive or. So one or the other, not both. So true, true. It cannot be both. So this is false. True, false. This is fine because this one is and this one isn't. False, true. That's fine because this one isn't and this one is. And false, false. That's going to be false because one or the other has to be true. So here's your symbolic form. Here's your written form. And here's your truth table for the exclusive or. Next, we're going to be going on to four types of arguments. Analyzing compound statements in order to find an overall truth value. These are found when you complete a truth table. Always look at the last column. So the last column would be this last column here. We can have different types of arguments. Contradiction is always false. The last column of the truth table has to be all false. A tautology is always true. The last column is going to be all true. Valid arguments are always true. Last columns of truth table, all true. An invalid argument, not always true. Last column is at least one false. Now, this video has run right now 14 minutes and 36 seconds. We do have these four examples, but what I'm actually going to do is make another video where these four examples are shown. So this first video was on just completing our connective truth tables of or, exclusive, inclusive, and conjunction, which is our conjunction, not, which is our negation, and going through what statements are Hopefully this helped. The next video is going to be on those 4 examples. Thank you.